In this video, we are going to prove this IIT limit using product integral. Now, first of all, what is product integral? Okay, so basically our Riemann integral was integral from a to the power b, integral from a to b of f of x dx, and this was equals to the Riemann sum. The Riemann sum from I equals to 1 to n of f of xi times delta x. Yeah, this is persistent integral when n tends to infinity. Yeah. Now our uh, product integral will be something like this. We have dx in the power, and the sum goes to product. We will have product of I equals to 1 to n. Now when sum goes to product, the product of these two will go to exponent. Yeah. Sum is, okay, since product is repeated sum, exponent is repeated multiplication. So that's why when sum goes to product, product will go to exponent. So we will have f of xi times delta x. So this is uh, our new product integral. Yeah. And we cannot, you don't have really formulas for evaluating product integral. So we can take product integral, we can express product integral in terms of Riemann integral, and that can be done in the following way. Basically, what we can do is we can take both, we can raise this thing to e to the power ln. Yeah, and that changes to sum. Okay, so let's see. So if we have limit n goes to infinity of e to the power ln of this thing, product from I equals to 1 to n of f of xi to the power delta x. Yeah. Now integral from a to b of f of x to the power dx, the product integral will be limit n tends to infinity of e to the power delta x times sum of I equals to 1 to n of ln of f of xi. Yeah, ln of product will be the sum of ln. Now we can take the limit to the exponent. We can do that. So that gives us limit n tends to infinity of sum from I equals to 1 to n of ln of f of xi times dx. Yeah. And now let me try to extend the page. Let me try to extend the page first. Now this is the product integral from a to b of f of x. Now I see that this product integral will be equals to e to the power. This is a Riemann integral. A Riemann integral from a to b of ln of f of x. Yeah, dx. So we have this really nice formula for product integral, that product integral from a to b of f of x is equals to e to the power integral of ln of function dx. So now we are going to use this very idea of product integral for this formula. Okay, now first of all, let us try to see that if this is a product integral or not. So we have limit n tends to infinity. N factorial is 1, 2, 3, 4 product up to n, and this is just n. So this will be equals to 1 by n to the power 1 by n, 2 by n to the power 1 by n, 3 by n to the power 1 by n, up to n by n to the power 1 by n. Now we know the product integral is actually equals to product of I equals to 1 to n, and then f of xi is actually equals to f of a plus b minus a by n times I, and delta x is b minus a by n. And when limit n goes to infinity, this will be a product integral from a to b of f of x to the power dx. Now over here, these two expressions, okay, so b minus a is not over here, since this is b minus a is actually delta x, it will be an exponent, b minus a by n. Okay, now b minus a by n is actually also known as delta x, and this is also known as xi. Yeah, now for this product to be equals to the original product that we have over here, we need to have b as 1, a as 0, yeah, and then in such case we will have 1 by n in the exponent, and over here this will be just I by n, so that's what we need over here, I by n. Okay, so this limit is actually the product integral from 0 to 1, and then f of x, and then f of x will just be, okay, so f of x over here is just x, yeah, because we just have 1 by n, 2 by n over here, so that's just f of x equals to x, and gives us these values, and then to the power delta x. Now this will be equals to integral from 0 to 1 of e to the power, okay, so now this integral is not like that, it's something like different. So this integral is now equals to e to the power integral of e to the power, now this is, there will be Riemann integral, log of function and then Riemann integral, yeah, as we had done over here. Now this will be e to the power x ln x minus x, Riemann integrals are easy, 0 to 1, so that will be e to the power, that will be 1 ln n minus 1, so that will be minus 1 minus 0 ln 0 will be actually equals to 0, because the x will dominate, and it x will also be 0, so this will be 0, so that will be e to the power minus 1 equals to 1 by e. So that's how we can solve this integral. Note that this was actually same as directly taking log over both sides and then using Riemann sum. Yeah, but we can also do it or show it as product integral and then do it, and this can be an efficient tool too if the product integrals are common, and the product integrals are also well known. If we directly know the formula for product integral, it could have been a lot shorter. If we directly knew that product integral of x is actually equals to e to the power x ln x minus x, yeah, just like we remember the formula for normal Riemann integrals, if we also remember formula for product integrals, then it could have been direct and just evaluate from 0 to 1. That would be a lot easier if this was normal, but anyway, it was just an application of product integral, and I hope you enjoyed this. Thanks for watching.